Okay, so making a little recording of the lesson. I forgot to record it yesterday for Nick, but it might be useful for any number of you just to review yesterday's lesson. So this is Wednesday the 24th of January. Just starting off looking at the core maths, the next type of questions that we need to deal with are ones involving fractions. And remember what we're going to do. We're basically going to multiply right through by x minus 2 and x minus 3 on both sides to clear the fractions. The big consideration here, though, is that when we get our solutions, we need to check that they do not make the original question undefined. In this question, x is not allowed to equal 2 and x is not allowed to equal 3. So we basically proceed with this. Once we've got, and we get rid of the fractions straight away by multiplying through by, as I said, by the lowest common denominator. Once we've got our solutions, we just check that neither of them is one of these, and if they are, then we need to discard those. Just look before you leap. So for example, here we don't need to multiply by x minus 2, x minus 3, and 2 minus x. We could change this last term to plus 2 over x minus 2, and now the only denominators that we need to multiply by are x minus 2 and x minus 3. Likewise over here, it's helpful to factorize the denominators first to see what we're dealing with. This denominator over here is actually a 2x minus 3 and a 2x plus 3. All right, and we can see we've got another 2x plus 3 there, and this one we can switcheroo by making it a negative 4 over 2x minus 3. Okay, right, so I don't want to talk more about the core maths now, but you should now be able to attempt the whole of exercise 5. Right, let's dive now back into the further studies maths. And we were looking at this question over here in our last lesson. In how many ways can I select a group of 8 from a group of 12? A committee of 8 from a group of 12. Well, if there are no restrictions, then it is literally just going to be 12, choose 8. 12 combination 8, 12 C8. I prefer the left-hand notation. All right, and I'm just going to quickly off screen here. In fact, I'll do it on screen. Just do that on my calculator. It's going to be 12 combination 8, and there it is. It's 495. Now, it gets slightly more interesting now because Justin will only serve if Roelof serves. So now there are basically two scenarios. If Roelof serves on the committee, so in other words, we put him on the committee, then we need an additional 7 people, all right, from only 11. And the reason 11 is we can't choose Roelof because he's already on the committee, all right, and so we need another 7. And we can choose any one of those remaining 11 people. In other words, we can choose Justin. If Roelof doesn't serve, and these are the only two possibilities, he either serves or he doesn't serve. If Roelof's not on the committee, all right, then we need 8 people, but in fact we can only choose those 8 people from 10 people. And the reason we can't choose from more than 10, Roelof's not available, and Justin's not available. Okay. Because if Roelof's not available, then Justin refuses to serve. Now, I think we need. I think hopefully it's fairly obvious. These are two separate cases, all right, and we're going to add those numbers. Okay, so if we just do those quickly on the calculator, which we've got 11 combination 7, all right, and to that we're going to add 10 combination 8. Total final answer of 375. Okay, what if Riley refuses to serve if Jeffrey serves? Okay, and again, it's helpful to consider the two possibilities here. If Jeffrey serves, right, then we need another 7, but we can only choose those 7 from 10 because Jeffrey's already been chosen, all right, and Riley's not available now, all right. If Jeffrey doesn't serve, we need 8 people, and we can choose those 8 from 11. Right, and the reason we can choose them from 11 is the only person who's not available is Jeffrey, but Riley is available. And once again, we're going to add these 2 different cases. Let's just get our final answer on that lot. So it's going to be 10 combination 7 plus 11 combination 8. Right, and it's 285. Okay, right. Onwards and upwards. So I wish to choose a group of 5 people from 8 to join me for dinner. What's the probability that Taku and Luke both end up in this group? Obviously, we're assuming that they're in the group of 8. Okay. Now, here we're going to use a very basic probability idea, and that's that the probability of something happening is the number of ways it can happen divided by the number of things that can happen altogether. All right. So the sample space, the total number of arrangements of groups, let's call them groups, the total number of groups of people that I could take, that's with no restrictions, is just going to be the number of ways I can choose 5 people from 8 people. And that's just going to be 8 combination 5. Right, it happens to be 56. Now, and that's on the denominator here. So this is going to be out of 56. Now, what I now need to work out is how many groups there are where Taku and Luke are in the group. Okay, so now, if Taku and Luke are in the group, then I need some more people. How many more do I need? Well, I need 3 more people, and those 3 people can only come from 6 people because I've already put Taku and Luke in the group. So I can't use them, all right? And I need 3 more, so 3 from 6. This comes to 20, all right? And my final answer there, so in other words, there are 20 groups which have Taku and Luke in. There's 56 groups altogether. And so if I chose a group at random, the probability that it contains Taku and Luke would be 20 out of 56. It makes sense. It always makes sense. Okay, right, now, so this next one is about vitality goals, and yeah, one needs a bit of information on this. But basically, you're not allowed to do more than 1 run in a day. And I now need to do 2 more runs. And I've got 4 days on which I can do those 2 runs. So I've got Tuesday, Wednesday, Thursday, and Friday. All right, and I need to fit 2 more runs in. I can't do 2 runs on a day. Right. So basically what I'm trying to choose here is 2 days from 4 on which to do my 2 runs. And that can be done in 4, choose 2, which is 6 different ways. Okay, so there's 6 different ways I can kind of satisfy and get my vitality goal for the week. Okay, right. So let's just write them down because it's only 6. We should be able to do that. I could run on Tuesday and Wednesday. I could run on Tuesday and Thursday. I could run on Tuesday and Friday. All right. I could run on Wednesday and Thursday. I could run on Wednesday and Friday. And the only last option is to run on Thursday and Friday. Friday. Right. And so we actually see that there are indeed 6 different ways that I can choose 2 days from 4 days. Okay. Right. Now, next up, we're going to look at what's called the binomial expansion. All right. And we know that when we multiply a plus b by a plus b, we actually get a squared. Because what happens is we need to take one factor out of each bracket and multiply it by a factor from the other bracket. So there are actually 4 possibilities. I take an a from here and an a from here. I take an a from here and a b from here. I take a b from here and an a from here. And I take a b from here and a b from here. Those are the only 4 things. Okay. Now, this, as we know, comes to a squared plus 2ab plus b squared, and it's a significant kind of mathematical truth that when you square a plus b, you get a squared plus 2ab plus b squared. Now, that has a sort of geometric representation. If we had a square here, all right, made up like this, where this little piece here is A and that's A. This longer piece is B, that's A, that's B, that's B, and that's A, and that's B, all right? What we've actually got here, we've got 4 shapes. The area of this whole shape will obviously be A plus B multiplied by A plus B. All right? But that, as we've seen, is actually an A squared. Now, A squared is that little area there. And then it's 2ABs. Now, 2ABs are, in fact, these 2 rectangles over here. Each of these rectangles has got an area of AB. All right? And there it is. And then we've got one sort of big square, which is B squared, which is over here. All right, and that's over there. So it makes geometric sense. What I did show in the lesson is the same thing with a cube, all right, with volumes, okay? And we've got that sort of model in the classroom. But what we're basically saying now, and we're going to try and sort of shortcut this, I can take an A from each bracket, and that can only happen in one way. Now, what I now want to look at is how many ways can I get 2 A's and a B? Right, how many different terms will have 2 A's and a B in? And likewise, how many different terms will have 1 A and 2 B's in? And then how many different terms will have 3 B's in? Now, these ones are easy. The A cubed are basically, there's only one way that can happen. It's taking an A from here, an A from here, and an A from here. It's exactly the same with the B cubed. The A squared B's are interesting because I could take 2 A's, I could take A's from these 2 brackets and a B from that bracket. Or I could take A's from the first and the last bracket and a B from the middle bracket. Or I could take an A from the second bracket and the third bracket and a B from the first bracket. There are actually 3, all right? And here there are 3 as well. This number over here, all right, what I'm looking for 1 bracket from which to take an A. All right, out of 3, and that will just be a combination. It'll just be 3, 1. It could also be 3, 2, because remember we've already discussed that 3 choose 1 is the same as 3 choose 2. When you choose one thing from 3 things, you're inadvertently leaving behind 2. So the number of choices, the number of groups will be exactly the same. Okay, now this has got cool application for something like this. If I wanted to work out the term in here, all right, which involves B cubed and A to the 6. Right. There'll be a term in here that looks like that. Okay, and that is going to be, basically I need to take A's from 6 of the brackets and B's from the other 3. So I need to choose from the 9 brackets, I need to choose 6 brackets from which to take the A's or 3 brackets from which to take the B's. It doesn't actually matter. Those 2 things are the same. All right. And what I'll see if I just go and work out that combination, all right, 9 combination 6, it's 84. All right. So when I expand this thing, there will be a term that's got 84 A to the 6B cubed. And likewise, there will also be one that's 84 A cubed B to the 6. Right, and I'm just going to use an online tool called Wolfram Alpha. All right, and let's just see if we can quickly load it. Wolf. Yeah, so what I'm going to do, we're going to expand A plus B to the power of 9. Okay, let's see what that looks like. Right. Takes a little while, but it's a whole lot quicker than we could do it. All right, there it is. And what we'll see here is that there's an 84A to the 6B cubed, and there's also an 84A cubed B to the 6. Right, let's put that away for now. Now let's look at another one. Find the term involving x to the 5 and y to the 11, because you see each term has something from every single bracket. So there's 16 brackets here. So if I've got 5 x's, I've got to have 11 y's. If I had, say, 3 x's, then there would be a term x to the 3, y to the 13. Cool. 13. These numbers always add to this power over here. All right. But the term involving that is basically what we're going to take is we're going to take x's from 5 brackets and y's from 11 brackets. Okay. And there's 16 brackets altogether. And so I need to choose 5 different brackets from which to choose the x's, okay, or 11 different brackets from which to choose the y's, because those we're going to get many terms that add up to produce a final term of x to the 5y to the 11 when we expand the thing. Okay, so let's just get that value off our calculator. 16 combination 5, all right, and it's 4,368. So there will be a term 4,368 x to the 5 y to the 11. Okay, and let's just quickly show that. X plus y to the 16. There it is somewhere over, hopefully. Yeah, there it is. All right, 4,368, x to the 11, y to the 5, and later on another 4,368, x to the 5, y to the 11. Okay, this one's interesting. Find the term involving x to the 6. So if I've got 6 x's, then I must have 9 2's. All right, now I'm still going to have a coefficient at the front here. Okay, even though this is actually 512, that's actually a number. And this is going to be, I need to take 9 brackets out of the 15 from which to choose the 2's. That is a number, I can work it out, and I'm going to need to multiply that by 512. Okay, so it's going to be 15 combination 9 times 512 x to the 6, and we can see what that's going to be. 15 combination 9 times 512, and we get 256, 2560 x to the 6. Okay, let's just have a look at that one. So 2 plus x to the 15. 6 by x plus 2 to the 15. And we'll see that our term involving x to the 6, if we can find it, there it is there, 2562560. Okay. And then the last one is just, if there's going to be a term in here that involves x cubed y to the 4, well, that means I must take x's from 3 brackets, all right? But the other term is actually 3y, so I must take 3y from 4 brackets. And I need to choose 3 brackets from which to take the x's out of a total of 7 brackets. Okay, and so that's what that term would look like. Obviously, when we raise 3y to the power of 4, that's an exponent idea. Both the 3 and the y get raised to the power of 4. So in fact, our coefficient, the number of these things, is actually going to be 73 times 3 to the 4, which is actually 81. And then I'm going to get my x cubed and my y to the 4. Okay, just to finish off this lesson, 2 little problem solving. Sorry, we're not out there yet. Jumping ahead of myself. These coefficients, these binomial coefficients, come from what is called Pascal's triangle. In Pascal's triangle, every row starts with a 1, and then what happens is that the in-between entries are generated by adding the entries above. So let's look at this row. We're going to start with a 1, then we're going to take a 1 and a 2 to get 3, a 2 and a 1 to get 3, and we're going to end with a 1. Right, and so it goes on. So if we just add in one more row here, we'd start with a 1, then a 1 and a 5 give us 6, a 5 and a 10 give us 15, a 10 and a 10 give us 20, a 10 and a 5 give us 15, a 5 and a 1 is 6, and then I end with a 1. And what we'll notice here is a symmetry, all right? So in other words, it's the same on either side. And what these numbers here are is they are the coefficients of our binomial expansion. So for example, this line over here is actually x plus y to the power of 4. Okay, and watch what happens. The x powers start at the maximum of 4, and the y's start at the minimum of 0. And then the x's reduce by 1 and the y's increase by 1. So each time, here we've got a 1 there, here we've got a 1 here. Every time the powers add to the total, okay? And the coefficients come out of the Pascal's triangle. So 1, 4, 6, 4, 1 there. 1, 4, 6, 4, 1. Okay. And these coefficients are generated by combinations. So how many ways can you choose 0 things from 4? Well, that's just 1. How many ways can you choose 1 thing from 4? That happens to be 4. This is 6. This is 4. And this is 1. Okay. This really is just for interest, this binomial expansion thing, a bit of extension. Right. Now, this is a cool problem which has now become available to us, okay? I want to get from point A to point B, and the way I'm going to do this is I'm only allowed to move right or down. So I'm just going to draw in a couple of options here. I could go down, right, right, down, right, right, down, right. Now I'm going to code that. I'm going to write that down. I went down, I went right, right, I went down, I went right, right, down, and right. Okay, so there's a path. Okay, I'm going to do another one now. I'm going to do a green one. All right. This time I'm going to go down, down, and then I'm going to go right, right, right. Then I'm going to go, down, down, right, 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 down, right, right. Let's write that down. Down, down, right, 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 down, right, right. Now, if we look at these, all of them have got 8. Every single path is going to have 8 things in, and it's in fact going to have 8 moves, all right, single block moves, and it's going to have always 3 downs and 5 rights. So really now the only thing I've got to kind of wonder about is, well, how many different places could I put the downs? Okay. So, and in fact, the answer to that is going to be, let's choose 3 positions for the downs out of 8. All right? Or let's choose 5 positions for the rights out of 8. Both of these numbers, I think, are 56. Yeah, I think they're 56. 8 combination 3. Yeah, 56. Okay. And so, in fact, there'll be 56 different ways that I can get from A to B. It's a cool way of solving the problem. Okay, because it's hard to kind of count them all by drawing it. It gets messy. Okay, now I added in a kind of bonus question here and said, like, of all those 56, what's the probability that my path goes through this orange dot? Okay. Okay, so what's the probability that I go through the orange dot? Okay, and what we need to know is how many of those 56 paths go through the orange dot. Okay, and we can quite easily work that out using exactly the same strategy, because the number of paths from A to the orange dot, I should be able to work out. Okay, and then the number of paths from the orange dot to B, I should be able to work out. Okay, so if we have a look at this, from A to the orange dot, these ones involve 2 downs and 2 rights. I could go down, right, down, right. Okay, so I've got 4 moves, and I need to choose 2 positions in those 4 moves to go right, or in fact 2 to go down. This comes to 6. Okay? Then to get from the orange dot to B, well, now from the orange dot to B, I've again got 4 moves, but this time I want to choose 1 thing from 4, because I need to go down once and right 3 times, or choose 3 out of the 4 positions to go right in. So 3, 4, or 3, or 1, 4. This happens to be 4. Okay, now the big question we've got to ask ourselves here is, are we going to multiply or add the 6 and the 4? And here we're in fact going to multiply, because any one of the paths from A to the orange dot, every single one of those can go with any one of the ones from the orange dot to B. Right, so there in fact are 24 ways to get from A to B via the orange dot. Okay, so 24 of the paths go through the orange dot out of a total of 56. So the probability that I go through the orange dot is just going to be 24 out of 56. Okay, the last question which we finished off the lesson with was, how many rectangles are there in this figure? And by rectangles, we're going to include squares. Squares are just special types of rectangle. Okay, and so what we're going to do here is we're going to try and count them, and they're loads, right? Because obviously there's this one here, there's this one here, okay, and so on. Right, in the next lesson, we'll look at how we can use combinations to answer this question.